a fluency component, which segues to the most mobile of the components in terms of position in the lesson, the application problem. Obviously, it's important to regularly do problem solving. Many lessons, including the geometry lessons, do not have number embedded within them or any opportunity really for word problems. Some are calculations, and so although we may start out with a real context, students need a lot of work from the Common Core with multi-step problems, and also revisiting calculations they may have done within the context of word problems, so they have a chance to always be applying what they've learned. So that's a separate component within itself. That is something that can be done at a different time of the day. We encourage all kinds of different approaches. We want teachers to get a sense of their class. At times they might be using a direct instruction approach. At times they might be separating students into small groups. One of our favorites is to have 2 pairs of students at the board solving the problem while others are working at their seats, and then have those 2 pairs share out their solutions to the class, so that children are often seeing more than one piece of student work, especially more than just their own. So that particular component is to invite application, obviously, but also to work with multi-step problems regularly, modeling them using the RDW process, which is to read, draw, and write. Well, can I draw something? What can I draw? What conclusions can I make from my drawing? Those 3 questions, unless they're repeated over and over again, students don't internalize them, and we need them to not be dependent on us to be generating those questions, but to have those questions within themselves, so that they ask themselves when they're faced with an intimidating word problem, because we know that the problem with word problems is the words, so they need something to get past that barrier, which is the drawing. And if we are mandating the drawing, if we're saying draw a tape diagram or draw this or draw an array, they're not necessarily practicing MP5, which is using tools strategically and getting to know, oh, I can draw a picture here, and that will in fact help me solve that problem. So convincing students to do that can really only be done within the context of often multi-step problems, because if they have a sense of the operations, single-step problems are often too easy for students to really feel like this is a problem I want to draw. So the application problem is multifaceted and multi-purposed, but we put it in so that it's always going on in the classroom.